in this tutorial we're going to talk about how to solve a free fall problem. We have a pebble, it's dropped down a well and hits the water 1.5 seconds later. We want to determine the distance from the edge of the well to the water surface. So we're going to start by drawing a diagram of what's going on. We have our pebble falling into water, and then we are going to write down our givens. And it looks at first glance like we only have one value, 1.5 seconds, which is our time. But there's some other keywords to look at here in order to figure out what some other givens are. One of the keywords that we see is the word dropped. Whenever you see that something is dropped, that means that it starts from rest. In other words, its initial velocity is 0 meters per second. The other thing that we notice is that it's moving through the air. And whenever something's moving through the air, only under the power of gravity, the acceleration is down, so it's negative, and it's down at 9.81 meters per second squared. What we want to solve for is we want to know the distance from the edge of the well to the water surface. We want to find this distance here. We use the letter y for vertical distances, so we're looking for the letter y. So we have our picture, our givens, and what we need to find. Now we need an equation. And because we wrote down that the numbers are representing these certain letters, okay, because we wrote down the letters they represent, it'll make finding the equation a lot easier. So now we go to our equations, and what we see is that there are the same equations for acceleration. The only difference is that we have y's instead of x's. We need to solve for delta y, so we're going to need a formula that has delta y in it, so I'm going to look for any formulas that have delta y. The first equation does not have delta y, and so that one is automatically eliminated. Now the other thing that we need besides delta y is we need a formula that has time, initial velocity, and acceleration. We see that the first formula has the initial speed, initial velocity, time, and the acceleration. So the first equation is the one that we're going to use. The third equation cannot be used because it has VF, and that was not one of the letters that we wrote down. The fourth equation can also not be used because it also has VF, and we did not write that letter down in our givens or find. So again, by writing down the letters that they represent, it helps us determine which of the four equations we're going to use. Now we write down that equation. We have delta y equals the initial velocity times the time plus half the acceleration times the time squared. At this point, we put in our values. Our initial velocity is 0. Our time was 1.5. And our acceleration, as always, is negative 9.81. Make sure you always put in the negatives whenever you write your numbers in your formula. As we multiply all that out, we get an answer, and we get an answer that is negative 11.0. Now, of course, we need a unit with that. Since it's a distance, the units are meters. And now the question is, why is it negative? Well, the reason that it's negative is because it's moving downward, and downward is a negative value. So it just indicates the direction. So whenever an object is moving down, make sure that your delta y is a negative number. And as always, we want to put a box or circle our answer, so it's easy to find.